Hello, guys. Good evening. Can you hear me?
Good evening,
Exactly.
sir.
Good evening, sir.
Yeah, welcome back from your long holidays.
Good morning.
Thank you, sir.
We just hit the ground and get running as fast as we can. So we'll get started. I'm using a trial version of Zoom. So once it locks you out, please try to rejoin. All right. Can you see my screen?
Not yet, sir.
Yes, please, sir.
Can you see?
We are seeing a dark screen.
Yes, sir. I can see machine and assembly language.
Okay, that's right. So I hope you have your writing materials with you. Can we start? Can we start?
Yes, sir.
All right. So this is what I've done is I've broken the course into different modules so that it will be easier for us to consume. I don't want to load you with the course material as heavy as it might be. So what we'll be doing is we'll be breaking it into modules. So for module one, which we are taking today, this is the outline. Can you see my outline?
Yes, sir.
Yes,
Okay,
sir.
so we'll begin with introduction to machine language programming. The second bullet point is supposed to be introduction to assembly programming. So pardon my error. So are you writing? Should I give you time? So we'll look at introduction to machine language programming, introduction to assembly language programming, and then we'll look at assembly to machine translation, assemblers, types of assembly languages, motivation for assembly programming, benefits of learning assembly programming, industries where assembly programmers are being hired, and then we'll close today with the distinction between a high level program and assembly language program. Are we together?
Yes, sir.
Yes, sir.
All right. So looking at machine language, or what we might call machine code, is a sequence of bits and bytes on which the processor logic operates. So what it means is that the logic of a processor can only operate on a machine code written with a machine language. So it is a collection of bits and bytes, and it uses zeros and ones. These are just to remind us or refresh our memories. It's what we've known already, what we've learned. So what a machine language does is that it allows one to program or to write programs in binary, in octal, or in hexadecimal um, number systems. The binary system is a system that allows only two digits, zeros and ones, and then the octal system allows up to 8 digits. between 0 to 7, while the hexadecimal allows up to 16 digits from 0 to 9 and from A to F. The machine language also, or is actually the actual language of the computer. It is the de facto language of the computer. That is what the processor itself uses as its own default or natural language. And because of that, it does not require any kind of interpretation or translation for the system to understand. It's just like if your native language is Yoruba, when one is speaking Yoruba to you, you wouldn't need any interpreter, any translator. If your native language is Igbo or it's Efik or it's any of the languages around the world, whatever you are speaking, if it is your what you might call mother tongue or what you were born into, you won't need an interpreter. You won't need a translator. You won't need an intermediary person to simplify the language to you. So for a computer processor, its own native language is the machine language, which is expressed in zeros and ones. As such, the processor will not need any form of translation of the language. So in this course, we're going to be writing assembly languages and see how the processor converts it into, what it understands using an assembler. So that's what we're going to be coding, or we're going to be learning in this course. Are we together, please?
Yes, sir.
Yes, sir.
Yes, sir.
Then looking at an assembly language.
Yes, sir.
Looking at an assembly language is a bit higher than a machine language. It is a human readable form of machine language or machine code. So what it means is that if a programmer were to write programs using assembly language, it would be easier for another programmer to read it, to understand it, to interpret it. And it is closer to what the machine understands, even though the machine doesn't understand assembly programs directly without the help of a translator. But then it is easier, it is closer to the machine. It's just like someone that is from Yoruba, and then that person actually comes from Ondo, and because Ondo has its own dialect, you will discover that if someone speaks the general Yoruba, the Ondo person will understand. But if an Ondo person speaks his or her own dialect, not every Yoruba person will be able to understand. Although there is a very close, tie, there's a very close connection. So an assembly language is like that with machine language, but it requires a translator, which we call an assembler. Then it uses English-like acronyms that are called mnemonics. So mnemonics are English-like acronyms or words that are used to express assembly programs or assembly language. So it is generally easier for humans to read and to understand. Codes written in assembly language require conversion into machine language. So there is a need for a translator, there is a need for a converter to change whatever a programmer writes in assembly into a machine equivalent. Have we gotten the difference, please?
Yes, sir.
All right.
Yes, sir.
So this is how it looks like. On this diagram now, this is assembly to machine translation. So on the left, you see a series of codes written in assembly language. On the right, you see series of bits, ones and zeros, which are machine codes. And then at the center, you now have an assembler. What an assembler does is to take the codes that are written in assembly language and then change it to a machine equivalent code that the machine can use. An assembler is a typical language translator that is used for a low-level program. All right. So you might want to ask further, what is an assembler? An assembler is a low-level language translator that converts assembly codes to machine codes. So typically what it does is that it converts the human readable instructions, which we call the source codes, into their machine readable equivalent, which are object codes. So what an assembly programmer writes is called a source code. What the machine eventually uses is called the object code. Please get the difference correctly. A source code is it's written by a programmer, an assembly programmer. Okay, so it's easier, it's closer to what the machine will know, but then there is a need for an assembler. So an assembler is an intermediary um, tool that takes whatever the programmer has written and then changes it into what the machine can use. It's just like the human body. When you cook your beans and you put your beans in your mouth, so your beans that the cooked beans you made is the source program, the source code, and then you put into your mouth, and then something begins to happen from your mouth. Biologists tell us that digestion begins from the mouth with the enzymes in the mouth. They begin to act on the beans, and then eventually the beans get down to your body, and after a while you pass out the beans. What your body uses, the energy your body uses is not the beans. Your body converts the beans into what it can actually use, and then it can extract the energy from the beans and use. So the beans itself is a source code. The energy that is being derived from the beans is the source code. Okay, and all of that is carried out by some form of processor that we have in our systems. I hope we are following, please.
Yes, sir.
If you have any question, just note it down. I will give room for
Yes, sir.
questions. So these are some examples of assemblers. Now we need to know that there are different types of assemblers, and there are different types of assembly languages. So an assembly language is not just one, like you have a Python programming language, or you have Visual Basic programming language, or you have a C# or C++. Assembly program is a collection of different languages whose syntaxes are very close, and the mode of operation is the same. Okay, so we are going to we will use a particular type of an assembly language to write, and use a particular type of assembler. So these are some common assemblers that we have. We have Microsoft Assembler, for short, called MASM, that's MASM. Then we have the Bolantubo Assembler, TASAM. Then we have the GNU Assembler, which we call GAS. We have the Night Wide Assembler, which is NASAM. Now there are other types, but these four are the common assemblers that we can use to write assembly programs. Okay, let me pause at this point and take questions if you have. If you have a question, you can put on your camera and wave your hand. Let me see. Any question from anyone? David, any question?
Sir, I have a question. Sir, please, can we brush back a bit on machine language itself before assembly language? I didn't really get it.
Your voice is too faint, something. Okay, go ahead. What did you say?
So I said, can we really brush back a bit on machine language, because I didn't get it before we go back.
Are you asking of the uses of machine language or what?
No, like a bit of how you explained it.
I can't get you. Miracle, what did I say?
Can you just explain a bit on machine language like this when you started? I didn't get it.
Okay. Can you hear me now?
Yes, sir.
Okay. A machine language is the native language of every computer system. what you might call the mother tongue of a person. So for a computer itself, its own mother tongue is machine language because it does not require any form of translation. Any language that one speaks to you and you need interpretation, it means that language may not be is not your default language, not even may not be. So if Endurance were to speak his own native language to you, obviously you won't understand. So you will need an interpreter for you to understand what Endurance might be saying. So for Endurance, that language he has spoken to you is his own default language. But to you it's not. So because when a program is written in machine language, there is no need for translation to be made for the computer to understand. So that makes machine language a default language of a computer processor. Is it clear now?
Yes, sir. Thank you, sir.
All right. So any other question, please?
Sir,
Yes.
so we can say that the machine language is just default language of the computer.
That's correct.
Okay, sir.
Yes. All right. Any other question? Okay, so we continue, right?
Yes, sir.
Okay, so these are some of the types of assembly languages. Can you still see my screen?
Yes, sir.
So
Yes, sir.
these are some of the types of assembly languages. So we have the ARM. So when the phone you are using, the hardware of your phone was developed using ARM assembly language. So phones that are running with Android, with iOS, all those mobile devices, the major assembly language type that was used in building them, in writing those programs, was what?
ARM.
Okay. And then for those of you who play video games using consoles, PlayStation, the video games were developed using MIPs. What did I say?
Video games
MIT.
So an MIP is a type of an assembly language that can be used to build the consoles that we use and the games themselves. I'm talking about the hardware that support the software that support the gaming devices. Okay, and then for personal computers like desktops and laptops, we use x86. What do we call?
X86.
86. You also come across the name as 8086. It's the same thing. 8086. So it has 16 bits, 32 bits, and 64 bits. It is actually an Intel product. Okay, so these are the common types. But for this course, we'll do our programming using x86 because most of us will be building for laptops. And then most of us will be using Intel computers. Are we together?
Yes, sir.
Yes, sir.
So the question is, what is the motivation for assembly language programming? You want to know, why are people still programming with assembly when we have Python, when we have JavaScript, we have Java, we have Node.js, we have all of these high level language programming languages. So why are we still programming with assembly? Why do I need to become an assembly programmer? Because it seems to be an old school, but it's not. The number one motivation is that assembly language programming allows direct communication with hardware. Are we together?
Yes, sir.
Now, take for instance, do you understand how ATM is able to dispense money? How it's able to respond to command? Those instructions were written with either assembly language or with C programming language. So it allows, assembly program allows interaction. So when you're writing for hardware, you can use assembly language to write. It allows direct interaction with hardware. Then number two, it is used to build device drivers. What do we call device drivers, please? What is a driver? Miracle, what is a driver?
The software that allows the device function.
A software that allows the device to function. Okay, that allows a peripheral to work. Are we together?
Yes, sir. Yes, sir.
Yeah. Now the thing is, if the moment you plug an external device to your system, take for instance you plug a flash drive. Once you plug it, will make a sound boom, and then it begins to do something. It begins to install a software. That software is on that drive that you have plugged in, and that software is called a driver. So once the driver is corrupt, your flash drive will not be able to work on that system. So you use assembly language to write those drivers, like your printer drivers, like your USB cords they want to use for charging or for transferring files from your phone to your laptop. You use assembly language to build those stuffs. And then you also use assembly language program to write or to design operating systems, OS, like your Windows operating systems, like your iOS. All of these all of these tools, all of these operating systems, like your Android, they are designed using assembly language. And then it also allows accessing specialized processor instructions. If there are particular instructions you want to give to your processor, like building firmwares are those programs that are written for hardware to be active. So you also need assembly language to do that. And also for building embedded systems like the IoT devices. You know, today, hello, are we together?
Yes, sir.
You know, you can stay in your room and turn off your generator that is outside, right?
Yes, sir.
Yes, sir.
You can sit in your living room and then turn off the AC that is in your bedroom. All this the most common one is your remote control for television. You sit from a distance and then you're able to turn off your television or turn it on. Now these things have programs that are written in assembly language. So assembly language is just that rugged, but there is really no hardware you will see that will not require either assembly language or a C language. So that is where it's very important for embedded systems design, and also for manipulating hardware directly, like your ATM card. They write something and then they print it on your card, and then when you slot your card into a machine, the machine is able to read it. Like your BVN card, like when you go to a supermarket, the use of this scanner, this QRS scanner, all of these programs are written using assembly language. So these are some of the motivations. These are some reasons that assembly language programming is important and is still relevant till tomorrow. Now, these are the benefits for learning, for you to learn. Number one is that it will allow you to understand how data is represented in memory and other external devices. It will enable you to understand how programs interface with your operating systems, your processors, and your BIOS. What's the meaning of BIOS? Patricia, what's the meaning of BIOS?
Basic input and output. Like basic input and output.
That S is what?
System.
Basic input and output system.
That's not correct. That S is not correct.
What has to do with
That S is not correct.
Software.
That's not correct. Daniel, would you want to answer? Where's Mabel?
So I'm here.
I cannot see you. I cannot hear your voice. What is that S for?
System.
So
My system.
What?
System. Basic input and output system.
Are you sure?
Yes, sir.
Where did you get that from?
System. Startup.
From the Britannica.
Okay. All right. Okay. Yeah. For some literature, they call it system, but it's actually set up. It's basic input
Okay.
and output setup. But some of the materials you will see online, they will call it system. All right. So can we continue?
I will go with this.
Okay. All right. So your learning assembly language enables you to understand how the processor accesses and executes instructions. It also enables you to understand how instructions access and process data and how a program accesses external devices. So these are some of the benefits of learning assembly language.
I go and buy notes. So I've not got notes.
And thereas, mute yourself if you are talking to someone else. Can you see hear me?
Yes, sir.
And you can see my screen.
Yes, sir.
So if you become an assembly programmer, these are where you might likely see yourself. You can work in aviation industry because aircraft is an automated system. Those engines that perform operations in aeroplanes are programmed with assembly language. Did you know that before?
No, sir. No, sir.
No, sir.
Now,
No, sir.
you might also be working in robotic labs. Many of the robots you're seeing are programmed using assembly language. And then bank, I mentioned the use of ATM. Even the door, at the entrance of the banking hall, the door that screens people in is programmed with assembly. So if you are a good assembly programmer, you might find yourself in any of these places. And then also in manufacturing, many manufacturing companies are automating their processes, and so they need assembly programmers to develop programs to automate their systems. And then automation centers and also computer hardware industries. These are just a few of them. There are many of them. And the thing is this, many times you will not see the vacancies for these positions being advertised. Have you noticed that?
Yes, sir.
What many organizations do is that they do secret recruitment, because these skills are the skills of an assembly programmer are highly in demand. Just last week, somebody sent me a message. We're looking for an assembly programmer, and they offered so much money to pay. So the market is massive, because there is no place for a software to rest except on a hardware, and for a hardware to be made ready, it has to be programmed. So that is why the skill of an assembly programmer will be highly needed at all times. So I encourage you, and it is easier to learn assembly language program than most programming languages. It's easier, as we will see. So what is the difference between a high-level language and assembly language? The difference is this: a high-level language program is machine dependent. machine independent. That is to say, it is independent of the machine that you've written it. So it means that if you write on whatever you write with Java, which is meant to run on a Java runtime environment, if you take it to a system that runs maybe a C++, it might not run because the platform is not the same. That is for a high level language. Although programs written in high level languages are easy for one to learn, easy to use, and convenient for managing complex tasks, then they use compilers, interpreters to translate. You know why? When you write a program in a high level language, that language is higher than what the computer will understand. So you will need a language translator to translate that program to what the computer can understand and can use. And what we use to do that translation, we call a language translator. And there are two types for high level. We have compilers and we have interpreters. A compiler is a type of translator that translates all the programs written all at once, while an interpreter translates the program line by line. So take for instance, when you are in the church and then someone is preaching in, say, in Hausa, and another person needs to interpret in English to the congregation. Now, each time the preacher in Hausa finishes one sentence, the interpreter will have to translate that sentence. The interpreter cannot wait till the end of the service or the end of the preaching before you begin to translate everything. No. So that is why we call them interpreters, because they translate what is said one after the other. That is for interpreters. So we have programs that interpret codes like that, while compilers will take everything in bulk and then compile them or execute them. That is it, to compile everything and then run them. But for an assembly language program, it is machine specific. It depends on the machine you've written it. And then it is the language that the processor directly understands. We've saved that already, and it uses a translator called assembler to translate to machine codes. So that's the difference between the two. Let me take questions again. Please ask questions.
Yes, sir. So I have a question.
Go ahead.
Okay, so while we are talking about the advantages of assembly language, we said it communicates directly with hardware.
Yes.
So does that mean only programs that are written in assembly language, and you mentioned C or C++, one of that. So it's only those programs that can communicate directly with an hardware. Apart from that, no one can communicate with it.
Those are the two major languages that are close to the machine. But then, out of the C and assembly is the closest, because C is a high level language. C requires the use of a compiler, but assembly does not require a compiler. It uses an assembler, which is easier for machine to even get. Are we together?
Yes, sir.
So the strongest hardware coding language is assembly. We have other ones. We have the type we call Verilog. Verilog is used in programming logic gate systems. Who is talking, please? It's cracking. Okay, are we together?
Yes, sir.
Yeah. The system will log us out. So once it logs us out, if we have not ended the class, please rejoin. Any other question, please?
Sir, please, I was thinking of something I wanted to ask. For example, this Google Voice Translator, is it written in machine, like that is assembly language?
Okay, a Google voice translator does not use a hardware. It's a software dependent. Are we there? Did you hear
Okay,
me?
sir. Yes, sir.
So it does not require assembly to do that. You can
Okay,
use
sir.
you can
Thank you,
use
sir.
Python to do that. You can use Java to do that, or even C++.
Okay, so okay, so sir, Python is capable of translating language. Maybe if
Yes,
I speak in English, it can translate to French.
yes. It uses machine, what we call machine learning, not machine language.
Wow.
There's a difference between machine learning and machine language. Oh. And did you get that?
Yes, sir. Thank you very much, sir.
Yes. So Python uses machine learning algorithms and models to build that translation. We call it natural language processing. So there is a plugin. There are tools that are used to do that. Our time is up. Let's rejoin, please. So do we have more questions?
Sir,
Yes.
we are talking about the difference between the high level language and the assembly language. So you said something about the high level language being easy to learn and easy to use. So if that is the difference, does that make assembly language not easy to learn?
Somto, your voice is low. It's running here. Please be audible.
Okay, can you hear me, sir?
Okay.
Sir, I was saying you said something about high level language and assembly language difference.
Yes.
And one of the differences we saw is that the high level language is easy to learn and easy to use. So my question is now, does that mean that the assembly language is not easy to learn and use? If that is the difference.
Okay. Now, why we say that high level language is easy to learn is because it uses more of English than what an assembler will use. Assembly language uses mnemonics. Mnemonics are acronyms. Are we there?
Okay, sir.
While high level languages use English like words. Now both of them use English like words, but the use of English like words in high level languages is higher.
Okay, sir.
That's what we say. It is easier to learn high level language because one, there is an active community of developers, so that when you run into troubles, you can Google things, you can get support. and then you see people who are programming like you. But for low level language, though the market is high, but the number of persons that are actually doing the job of coding with assembly is fewer. So if you want to learn now, if you need someone to teach you programming, now they will not ask you whether you want to learn assembly, because it is rare for people to want to learn assembly except those who are in the industry. But for those who are working for organizations like that, all these firms around, they majorly make use of high level languages. So that's part of what makes it easy for people to learn.
Okay, sir.
Yeah. Tojuba, David, Mabel, who is this item?
Yes, sir.
And Emmanuel Adeniro, Miracle. Questions? Daniel.
Sir.
Questions? Who is Oni? You have questions, please. Which one is
Yes,
that,
sir.
Dada?
Onimayowa.
Okay, Onimayowa. All right. So I'm going to drop the PowerPoint on the WhatsApp group for you.
Okay, sir.
Okay, sir.
I will also drop a link to a YouTube video I need you to watch on this class, so that in the next class we'll pick up from there.
Okay.
That's very good, sir.
Okay, please go through the PowerPoint, look for other materials online, and then read up. We'll meet again next week.
Thank you.
Enjoy your evening.
Thank you.
Thank you, sir.
Bye bye.
Thank you very much, sir.
Yeah.
Don't look at that.
Thank you, sir.